short introduction. It was a, but
So
it's
there are
okay. It's
many
okay.
things that I skipped actually, but I shared
Yeah,
your biodata with all the participants in our WhatsApp group.
yeah.
Yes.
Thank you, madam. And this
Yes.
is happened because of the, I think it's age is a very important factor. I'm 50 years old. So I've got the 25 years of teaching experience, and that's why this kind of various dimension and
But
their
it's a
activities
great
is
work, sir,
possible.
actually. We learned lot
Thank you.
many things from you people.
Yeah, thank you, madam.
Yes,
And
yes.
thank you very much. Yes, I am in charge of the one center also, that is the Electromagnetics and Antenna Research Center.
Yes,
That
sir.
is the only center in the Gujarat who is dealing with the antenna research.
Ji.
So let me give a brief introduction of the my institute first of all, because I am this is my responsibility also, because we are the institute which is the first engineering college of Gujarat, right? And obviously we are our existence is happened in 1948 with the generous donation by the GD Birla Sahab. The Birla Sahab was the from the Rajasthan. He was a businessman. He has given the donation of the 25 lakhs in 1948 to my institute. That is the government-aided institute known as Birla Vishwakarma Mahavidyalaya. So we are also the first engineering college of the institute, I mean in Gujarat, who got the UGC autonomous status. And obviously we have so many mentors and creators of our institutes, and this legacy that we have to take care. And that is the, I mean, we can say that the very heavy responsibility to us. So we are trying to justify those things, yeah. And obviously, the institute is, as I said, was established in 1948, and we are NB accredited. We are also a NAC accredited institute. Right? So individual institutes in Gujarat, we are the first who got the, as far as engineering is concerned, who got the NAC status. Right? So that is possible because of the our senior faculties and the alumni and the other stakeholders like students and our management. Say. So these are the few information on it. That's we are running with the 16 courses, uh, and we also added one, or rather, it was also the our practice of the evening college. But evening only we are allowing the part-time studies, PDDC in mechanical. So we have a UG 9 institute, 9 programs, and post-graduation 8 programs. This one is our vision, that because we are situated in the place where the this we can say that it is a village kind of environment. Now it is also developed, but still our goal, or rather our vision was or still it is continued, that is produce globally employable innovative engineers with the core values. As far as missions are concerned, we believe that the re-engineer curricula to meet the global employment requirements, promote the innovative practices at all levels, imbibe core values, reform policies, systems, and processes at all levels, develop the faculty and staff members to meet the challenges. So I'm also involved in the non-teaching and teaching training programs with the principals, and normally I organize the staff development activities. Yes, we have a good governance systems, like a board of governance are there, and the other facilities as the other institute have available, same kind of facilities, and something can be a eye-catching, maybe RFID assisted libraries are with us. We have a innovation and an entrepreneurship shell. We have a VM skill lab. Likewise, there is the other like a World Bank assisted project. So we have received two projects. So in the Gujarat Institute, we are the second, because SVNIT, NIT Surat, that is a National Institute of Technology, and second is my institute, that is a Birla Vishwakarma Mahavidyalaya, got this project. And we have got the 17 crores rupees from the World Bank assisted project, that is a TEQIP. And under this, we have done so many development in our institutes. So we are thankful to the government of India in this regards also. Yes, we are the brand values, as I said, our alumni, they are donating very good amount of generous fund, and we are establishing the new buildings, new classrooms, and so many things. Because as you all aware, the alumni are this one is a very important stakeholders, and at the same time, they support like anything. So if you see the IITs, NITs, or very important institute like the central universities, I think alumni, they are the backbone of this institute for the development. Yes, we have a 19,000 plus alumni database, and they are ready to support the institute at any time. So that's why there is a very important situations. Some of the alumni, they give the funds, some of the institute, they give the time, some of the institute, they share the expertise, they give the knowledge to the students, right? So there are every kind of, we can say that the analyses, that's every kind of supports are given by the our alumni. Yes, we are following the outcome-based educations as per the AICT's recommendation and the recommendation by the National Board of Accreditations. And we have also strengthened the best practices like MOU with foreign universities. We also done these four international conference and also collaboration with the other institutes that was known as the GC Banswara Rajasthan. We have supported, I have acted as a training coordinators. So because there was a one important guidelines given by the government of India in this regard that you have to mentor the one institute. Let's do this things. I think the institute can be also explore. So nowadays, GC Paswada is doing excellent work, and with them we have also done the 8 conferences together. Say it's a joint conferences. This one is a simple one page detail of my lab. So this one is electromagnetic and antenna research center where we can do the testing of the microstrip antennas, and we have already helped the NIT and Surat students. We have helped the all private universities and the government universities of the Gujarat. So their researchers, they came to us and we helped for their research parameter measurement and all. So obviously, even I have helped the one of the student of the NIT Nagpur also. That also I've helped. So that's our it's our humble duty also. When people are coming to us, we should help. I think that will give a better outcomes. Yes, this one is the MOUs that we have done the 85 plus industries based MOU. And this one is the company known as the Entupal Private Limited, Bangalore. The CEO of Entupal, Mehtaji, is present here with our chairman of Board of Management. Yes, we have done we have signed the MOU with the foreign university. This one is a glimpse of one conference where the Illinois professor was also in our campus, and they also done the MOUs on behalf of their universities. Now I come to the point that is the what is the we are going to deliver, right? So it's a microstrip antennas for IoT and other applications. As per the information given by Professor Preeti Madam, that the mass, those who are present here, they are from the IT, they are from the computer science, they are from the electronics science of electronics, right? So let me try to give informations that is useful to that. Microstrip antennas for IoT and other applications. So as you're aware, nowadays antennas size becomes very small. Antennas becomes very compatible with any systems. And so I am just because in IoT you have to do the joint work together. You have to take care of the IT or computer peoples and electronic science. If they work together, so it's interdisciplinary kind of applications. And nowadays, interdisciplinary concepts are, as you know, if you see the patent, if you see the any system development, you have to take care of the 2 to 3 departments. They work together, and then there is a something can be a outcome. So with this, as you know, there are some of the faculties or some of the experts, those who are present here, they are already aware about the various kind of antennas. So ready-made antennas are being used for our system development. So this one is a smart IoT applications and environments, means what kind of key antenna consideration. So there are so many antenna. If you see in the screen, the antenna size are different, antenna types are different, antennas frequencies are different, antennas ranges are different. So depend on the what kind of application or my target parameters is needed, I can select the antenna. So I can see here the some of the antennas like a monopole antenna, something like a straight wire kind of antennas, some antennas where the microstrip antennas, where the structure is a PFA structures. Somewhere I can say that there is a microstrip antenna structured. Somewhere I can say that it's something kind of loop antennas. So every antennas are useful for IoT applications because IoT applications, it is your applications decides based on range, based on frequency, based on power, right? Based on what is the bandwidth requirement, and that's why one can select the antennas. There is a key antenna considerations because when I say IoT, obviously you have to send your signals in a wireless manner also, in a free space. So smart IoT application and environments, let us see that part. So here is a microstrip antenna. Microstrip antenna is actually a antenna which is the very low profile antenna. The antenna can be considered as a very small in size of antennas. And if you see here the structure, which is mentioned just in the right hand side of the microstrip antenna words, the layer, upper layer is a patch, below layer is the ground. And if I see the width and L stand for length, the dielectric means it is basically the thickness involved. Total thickness is the including with the ground. So yellow color is the conducting material based, right? So obviously it may be a copper. Copper is mostly preferable, but you can also change the material based on your requirement. So there are so many research are already being done. There are so many different materials are there. And as far as the cost is concerned, low cost material is the FR4. What we are basically used for a PCB design. The same material is FR. If your student is you wish to work with the different material like some kind of PTFE materials, some kind of polystyrene materials, some kind of other conducting materials, then they can they can go with the they can go with the various vendors, those who are developing this material. They can develop their own also, but there are so many industries or companies that are available. They offer you materials. If your students are doing research, you can ask them for the free samples. So when the student can send this request with your signature, with their ID cards, they will get the free of materials. Because I'm using this, I am means my students are using these materials. So without cost, also the research is possible in the antennas because you need a software that is a simulation software. Then you need a material that can be get it from the industries where the free of cost material is also possible. Or you can design on a low cost material, that is FR4. Cost is very small one, as you are aware. So patch is I can say that the patch may be a circular patch may be a square patch may be a elliptical, patch may be a rectangular, patch may be a circular or ring structures. I can use a dipole kind of structures. These are the different shapes of the patch. Ground plane is always needed because signal is basically observed side by side. If you are giving a signals from the center, because it is a microstrip feed lines, you have to energize this. Otherwise, it is a dead microstrip antenna. Right now, it is a dead microstrip antenna. But if I'm giving signal, then it gives a radiation. It becomes live. So radiation means that the at the two sides, left and right, from the microstrip feed line, from where I'm giving a signal, the signal which is possible, that is kind of fringing field is produced, and this field is basically has the same directions, and that's why it is added, and finally radiation is happening, right? So this one is there. Then let me go with this some introduction part. So wireless connectivity is a critical enabler for many of IoT applications, particularly those that needs to be mobile or where cable data communication is not cost effective, right? Or practicable. Popular wireless protocols includes Bluetooth, Zigbee, and Wi-Fi, and that is normally operated at the frequency that is a 2.45 gigahertz or 5 gigahertz. And that sustains the high data rates over a relatively short range. Standards such as LoRa, nowadays we are using a LoRa because the range is very good. Cost effective solution is this. Our student can do a better project on it. So standards such as LoRa and Sigfox support connections over a longer distances at lower data rates, and it can be operated in a sub-gigahertz bands. Then, designing an RF subsystem based on any of these protocols demands special skills, right? Basically, we are doing so many activities parallelly during our job. And we are also concentrating on research. Nowadays, as you know, the research outcomes are asked by the higher authority also. Obviously, I accept it that is the individual interest. But if you have a good student, you can guide them, you can motivate them, you can mentor them. There is always definitely a good outcome is possible. So there is when we adopt the wireless modules or a reference design that comes with the protocol stacks that already integrated and critical hardware layout issues being solved, while this can greatly simplify design challenges, achieving a working solution is not an easy plug and play enterprise. So in a world of uncertainty, technology is the one constant that continues to move us forward. As you know, we are talking about C-band 15 years back for the satellite communication. Now we are talking about KU or Ka or higher. We are talking about Wi-Fi with this amount of frequencies. Now we are talking about the giga, maybe more than 60 gigahertz of the frequencies. So there are so many updates, even though 4G to 5G, when we transform, obviously the frequency requirement is increasing because demand of the frequency or bandwidth is increasing. If the bandwidth demand is increasing because you have to now, you must have to be comfortable for a video calls, video conferencing, or any data, right? Your download, your data collections or everything should be very simple or very fast. And that is possible by the 5Gs. But 5G's frequencies and subbands are in a gigahertz, maybe more than 30. Subband maybe a 6 gigahertz. So point is the frequency demand is increasing. And as I say, technology is the one constant that continues to move us forward. So mission to create a safer, sustainable, more productive and connected future now is the more evident than with the emergence of the Internet of Things, the system of uniquely identified interconnected devices that are unable to transmit and share data over wireless networks. So let's have because when I say wireless, maybe virtual, that the system, physical. So bridging the gap between the physical and virtual worlds, the IoT is helping to create a smart environments by linking this device to everyday setting and tasks that help individuals, businesses, and potentially all societies live in a smarter and a more comfortable way. It's growing fast. That is also very important. Machine to machine communication utilizing a low power network such as ultra wideband, wireless local area network, Zigbee, or Bluetooth to transmit data have helped to drive IoT adoptions. But even more, so it is advent of a low power wide area network like NB-IoT, LTE, CAT-M, and 5G, high efficiency transmission that has fueled the IoT growth. Why IoT is in demand? Why it is considered as a very emerging area? If someone is writing proposal on IoT, machine learning, artificial intelligence, right? That is always accept. I mean, there is more chance to accept those proposals. So while 3G and 4G networks facilitate wireless communications among people, 5G allows for the greater connection among things, posing a paradigm shift that has directed a focus on developing sophisticated IoT solution for a range of industrial and environmental concerns. Because we are talking about IoT, but there is a double IoT also, right? Industrial IoTs. So there is always demand is increasing, and that's why IoT become a very important choice for the next system. This has set the stage for a wide range of applications where meaningful change and efficiencies can be affected. IoT smart antennas now can be as diverse as a farm that better manages its irrigation systems. With so many faculties and respected teachers are present in this August gatherings. They have also done in this kind of projects in previously. But system becomes more smart and smart, right? Because what I'm using, maybe I also developed with the our students project. The students, those who are living in Junagadh districts, there is a Girnar mountain, the area where so many jungles are there. lions and the other animals are moving. So where the farms and their irrigation systems are so much difficult because on that time the issues are somewhat different. So you have to control it from a distance. Maybe from home you can see the situation of your farm. From the home you can at least see that the can I start the water pump? Can I give the water to the plants? Yes. So that students have done, I think, 10 years before the project was also. But because it becomes more smarter and smarter because it was GSM enabled. Now the IoT means from the world you can do. Because when I say IoT, it means from the any place of the world I can do it. Only I have to require the internet and the other supporting systems. So equipment maintains to a major city seeking to create more effective utility, metering, street lighting, energy, and other resource management, and predictive maintenance of its facilities and operations. So there are so many applications are possible. Let us see some survey, which is very important because IoT growth forecast is very important. Why I should go with this? So there is a cellular and non-cellular IoT connection will triple worldwide between 2018 to 2015, and we are going to reach the 25 billion. Global IoT revenue will increase at an average annual rate of 23% to reach the 1.1 trillion dollar by 2023, a fourfold increase on 2018. Global IoT spending will return to double-digit growth rates in 2021 and achieve a compound annual growth rate that is a CAGR of 11.3% over the 2020 to 2024. This is the forecast period. So IoT performance rest on other technologies. And out of this, let's concentrate on the antenna because I'm doing little bit work on it. I am guiding my PhD scholars. I'm helping them. I'm motivating them to do the best results, to do the best research. So as IoT growth has been fueled by technology, it also has been facilitated by the strength of other technology advancement. Antennas are critical to transmitting and receiving the radio frequencies, RF, and along the filter and power amplifiers. It must work adaptively with fiber optics and cloud-based technologies. This is also very important. Adaptability of the system is very important, how it is compatible with the other exist system or technology. They must also enable near limitless wireless connectivity between devices and databases, while at the same handle high power signals and operate within a stringent thermal condition. These are the functionality all critical to the development of an IoT application and performance of a smart antennas, smart environments. So IoT performance rests on the other technology that is antenna because there must be also enable the near limitless wireless connectivity between devices and databases, while at the same handle high power signals and operate within the stringent thermal conditions. These are functionality all critical to the development of an IoT application and performance of a smart environment. Antennas play a complex role in the dynamics of the IoT. Because if you are not going to design, it is okay, but you must understand the selection of your antenna. So antennas are integral to the IoT application as IoT ecosystem moves to support high density, low latency networks. and continue to incorporate various new features into radios and overall system layouts, there is an even greater premium put on antenna system design. As you know, the antenna may be a optional or embedded part of IoT, but it is considered as a integral solution. Because when I use the antenna, there are so many other complications may happen. We have to take care of because the frequency is increasing, so radiation is increasing. There will be a electromagnetic radiation, electromagnetic interference should be taken care. Then we have to go with the EMC, that is the compatibility. There is always the EMI EMC clearance certificate for your systems, otherwise you cannot launch it. And that is totally based on the antennas and all. Because wireless systems, it has a issue of the emissions or radiations, and that is basically done by antenna. Continue with this point, means antennas are integral to the IoT application. There are so many examples in the market of how multiple antennas are being used to work with the 5G networks and support IoT applications. So active antenna system AAS are commonly adopted to increase the capacity and coverage of radio systems streams. They also features a tightly integration of a radio frequency electronics with a massive element antenna to enable the miniaturization and boost efficiency. Because nowadays people are not using a single antenna. There is a multiple input, multiple output. That is the MIMO kind of structures. Because single antenna cannot serve the purpose of wide bandwidth, high gain, good direction. I mean, signal strength directions must be a good in all directions. No, single antenna will not serve this purpose. So, and that's why in a 5G networks, the MIMO, multiple input, multiple output kind of concept is being used. And that is very important. So, as you know, in IoT also, that can be think of. System comprise an array of antenna closely integrated with hardware and software components to increase the system complexities. This includes the greater steerability for adapting antennas, radiation patterns to rapidly time varying traffic and multipath radio transmission conditions. Simply, more antennas translate into a faster data transfer, the lifeblood of the IoT. IoT can be live, can be on by faster data. So more antenna translate into a faster data transfer. So then the point is comes here that how can I select the right antennas and customizing solutions. So the complexity of antenna system design and the availability of more frequency bands afforded by 5G have made choosing an antenna for a smart device that much more challenging. System designs cannot rely on plug and play options, but instead require more sophisticated planning and a holistic assessment of all connectivity requirements. This is very important. Hence, the selection of the antennas for a smart not in the task. So in a variety of IoT applications, it is not unlikely that an antenna solution will need to be customized and include 2 or 12 antennas product inside a device, often the size of a mobile phone. These antennas must manage different redundancies and services while working clearly and independently from one another. So how we isolate the antennas within a system design, that is also important because there is unnecessary radiations that will also downgrade the performance of antennas. So this is another critical issue to consider in designing an antenna system for a business, industrial, or real world IoT applications. They must be designed to operate on secure networks. While there are a range of antennas that can be used for Wi-Fi, Bluetooth, and GPS applications, there is increasing reliance on a cellular antenna that offer the critical features needed for IoT success. So separate applications have a separate antennas requirement. So for example, with the exponential growth of wireless traffic posing more and more interference, spectral efficiency is the key. When I say spectral efficiency means how I utilize my spectrum efficiently. Because bandwidth may be allocated to you is 50 megahertz, let us assume it. Are you accommodating the all number of channels in this frequencies? Are you utilizing all the band? So as a result, the antenna must also be able to handle this bandwidth issue. Cellular antennas effectively meet this requirement. That's why it can be used. So there are types of antenna like a cellular, LTE, 5G, GNS, Wi-Fi, Bluetooth, GPISF, LP1. And when I choose the antenna as IoT antenna, my requirement is very clear. So first is a high efficiency for a clean transmission and optimized battery life. High quality transmission, signal interruption, again, the interference or noise, harsh environment durability, robust design in a dry and moisture prone areas, compact design miniaturization, multiple frequency operation, need for more bandwidth and compatibility with the global cellular networks. Shorter development cycles and reduce the cost. So these are the some six requirements point and starting from the optimized battery life and the high efficiency for clean transmissions to the reduce the cost. So together, these various technical and marketplace demand make clear that innovative and secure antenna systems are needed for IoT applications. The engineers who design this system must also fully understand how antennas operate in a wide variety of technical and governing circumstances. Regardless of the situation, however, the time for a bad antenna is over. That's very important. So, what are the essential part for the smart IoT environment or a smart antenna system design? So there is a rapid growth of the IoT is allowing for the creation of a small environments. One should be committed to identify the real world situation where the ability to effectively collect data and gather knowledge can lead to developing sustainable to IoT applications. Excuse me. So focused on a smart antenna system design, it makes sense to look at two major trends in IoT applications. One is to work in this area, they can do a lot of business in the future. First one is a smart tracking, and second is a smart building. So in both these cases, examine the market issues, challenges, and requirements that clients face to develop the optimal solutions. Regardless of the applications, there are clear standards that must be met in focusing on a data management and protection as well as backup battery performance requirement. Other pertinent standards focus on installation practice, firmware upgrade, communication device diagnostic, and climate resistance measures as the environment in which an antenna operates with impact its a function. Smart tracking means it is a growing trend presenting a significant market opportunity for companies looking to enter the space. It is increasing being developed for the it is increasingly being developed for using telematics and onboard diagnostics because nowadays the telemedicine concepts are most popular. From a distance, I can get the advice from the doctors. Two major areas within the global vehicular and transport industries that are experiencing a significant growth. It is also used for the asset tracking of physical assets, again used in a transport as well as with the global distribution and logistic players. Another area of growth, the IoT supported assets tracking market is expected to account for a 93% of all enterprise and industrial IoT solution in the current environment that we should take care of. So in building a smart tracking applications, a customer has to consider a number of technology challenges. Requirement to ensure the right antenna system, that is very important. And if you see the challenges and the solutions, some of the challenges are there. One can work on it. Controlling the orientation of the antenna as well as its radiation pattern performance. Because basically, when you increase the frequency, you need a large amount of bandwidth or a gain. And when the frequency is increased, the gain is increased, I think it becomes more directional. So solution of this challenge is operate with the multiple frequencies and provide a omnidirectional performance. If I have a different frequencies, I can use at the angle of 120-degree with the sectoral antenna. Sectoral. I hope you've seen in the any tower. If you find it, there is always three structures. Harsh environment condition that offers the robust design in a dry and moisture-prone areas, uninterrupted cellular signal for diagnostic performance. Let's deliver high efficiency, battery power savings, ensure the high efficiency to prolong battery life, global tracking, provide a service across the globe, ensuring multiple frequency bands. Situations are following two issues were dramatically impacting performance. First one, an IoT startup business focused on a global tracking was using a variety of antennas that made their device bigger, heavier, and more expensive to produce. They were also using a cheap antenna that did not allow for the granular tracking data needed, nor did they understand the complex radio frequency band requirement. Because as you know, the size of the antenna is decreasing. There are so many other complexities are also increasing. But to cope up the requirement, I think one can do it. Custom designed embedded antennas for a 5G connectivity that enable the customer to build a reusable smart system more as a mobile phone than an IoT device for a real-time parcel tracking, reducing the weight of the antenna to both lower the cost and size of the board, as well as improve the performance. That you see this. When the weight of the antenna is decreased, that curtail down the cost and size of the board, as well as the performance is also change. So implementing on a board surface mount device antennas to make the entire device part of the antenna solution. This also created the most efficient and repeatable manufacturing process. We have to review the design to improve the battery life and reconfiguring the board layout to properly place the radio frequencies component and maximize the ground plane, which enables radios to work and avoid interference. Antennas and RF components tends to be the most underestimated parts of a design. Engineers with antenna and RF expertise can help bring the specification of an IoT product of life. Those who are doing good work on the antennas design, they can guide, they can maintain the legacy, they should help the others. Next is the smart buildings, and that has become one of the fastest growing technologies. The primary market driver behind the development of a smart building is the growing concern over energy utilization. Let us see the challenge of the smart tracking and how we can combat it. Physical construction material, maybe metal, maybe concrete, can impede the antenna signal. Solution is there, and it gives that deliver high efficient antennas, whereas signal performance is not significantly affected by the building construction materials. Interference or congestions, competition between wireless services creates interference and signal noise can block service, causing access point to compete for services. As far as solution is concerned, it will ensure the clean, free of interference transmission. Very little high frequency background RF. So solution is implement the right antennas. Inability of 5G to penetrate windows and wall from the outsides. Resilience and security requiring license frequency band certifications. Let's see the solution of the inability of the 5G to penetrate windows and wall from the outside. It includes the microcell and small cells to enable 5G performance inside the buildings. And solution of this one is provide engineering support and expertise to deliver successful IoT design and certification support. So I'll give a 5 minutes break here. I'll just join within short time, please.
Okay, sir.
Please. So I have to sign one document, please, 1 meter.
Yes, sir. Yes.
So sorry for interruption. Yeah, please. So let's see the situation because challenges are there and we have a solution. So there is a real estate developer constructed a smart building in a major metropolitan area to enhance the building management and provide the tenant amenities. The building was designed to feature significant securities and surveillance protocols, real-time energy reporting to lower costs and increase efficiency, and predictive maintenance models to avoid problems and save costs. Because nowadays the smart buildings are the future, even smart cities are the futures, because with the help of IoTs and other applications, one can also ease the local issues of the maintenance and so many things. But there are a solution. Floor plans include the smart lighting, air quality monitoring, and intelligent parking capabilities. These all are the electronic systems which is possible with the help of computer IT supporting system. Cybersecurity was also addressed as a paramount issue since the smart buildings are more exposed to the potential for a cyber attacks. So when I use the antennas for the IoT application in the buildings, MIMO antenna assemblies enabling high quality wireless servers to deliver uninterrupted extended range and seamless multi-user experience as well as it brings the cellular network service from the outdoor to indoors. As I said, multiple input, multiple output. Single antenna will not serve the purpose of the large amount of bandwidth, the high data rate, right? So frequency of operation is increasing. At the same time, if you have a multiple input, multiple output, I think in the all the direction you have a sufficient amount of radiation of the signals with the good range coverage and all. So embedded antennas to support the smart indoor cameras and cloud-based automated access control systems, including customizable credential options such as a mobile application, personalized keywords, key fobs, and links sent to the mobile phones. 3D antennas assemblies to facilitate the real-time monitoring of electric, water, and gas meters to a lower energy cost, increase the energy efficiency and secure energy supply, all while reducing the carbon emissions. Cloud visualization to monitor and maintain a building from miles away, including real-time alerts and visuals. You can, I mean, we have seen these so many advertisement of these electronic systems. You can control it from a distance. You can control it from the other countries also. So robust onboard and 3D antennas to facilitate the building of various smart energy saving technologies into hubs and group control functions for lighting, temperature, humidity, and other factors with the data sent to the clouds. Secure the coding standards and penetration testing practices in cellular antennas to ensure they remain strong and release software security updates to patch newly discovered vulnerabilities. So there are so much system requirements, so much system updates. As I said before, the technology can be, we can say that the only the solution of these things. The system is the antenna, so among the challenges that must be dealt with selecting and integrating a suitable antenna has a significant impact on the RF subsystem. And consequently, it affects the system performance in terms of communication range, overall power consumption, and battery life. This is very important. Three parameters are very important. The antenna is often required to fit inside the device enclosure, which usually demands small size and careful positioning to ensure the optimal performance. So selecting antennas, again for a small IoT devices, the system is the antenna. So on the other hand, a suitable antenna should also have a high efficiency, adequate bandwidth, covering the desired frequency range. As you are aware that what is the bandwidth? Bandwidth in the antennas means within this bandwidth, antenna performance are maintained. And that can be observed on the device known as vector network analyzer. Cost of this VNA is very high. If I assume there is a 10 gigahertz or 20 gigahertz, per gigahertz roughly is a 1 lakhs costing. So if I have a 20 gigahertz of the vector network analysis system, the price is something about 20 lakhs or less, mine or less than like 18 to 22 lakhs. So that's why it is the best to consider the antenna design issues as early as possible in the project on the basis that from an overall RF performance standpoint, the entire system is the antenna. Because we were basically, I mean, normally we are collecting these systems or purchase this system directly, maybe compatible, no, maybe not compatibles. Because if you have purchased the complete system, there may be a chance of compatibility. But if you have a two various system design, like one is the system and second is the transmission reception part of means the antenna. If you have a separate company's antennas or separate company of system, you have to take care of the compatibilities and all. So basically the integration of the antenna is possible because that is the main use of microstrip antenna. A PCB antenna can be attached to the main circuit board above the ground plane. The ground plane must be the top layer of the main circuit board. PCB antennas are intended to be mounted at the edge of the circuit board. This is a very important thing that antennas and especially the microstrip antennas are always connected or integrate with the body of the systems. So PCB antennas are intended to be mounted at the edge of the circuit board. If space constraints inside the enclosure demands more flexibility in positioning the antenna, a PCB antenna can be connected to the main board using the miniature coaxial cables. I can use the cable to connect it. So stamped metal antenna is a suitable alternative because it gives you a high speed. If a space is extremely limited, then 3D antennas can be used. Although an antenna can be selected to have the same impedance as the RF amplifier output, loading by nearby components on the circuit board, and the material properties of the device enclosure may require a matching network to be inserted. This can be a simple single series capacitor and parallel inductor for a single band antennas or a more complex network for a dual band applications. Because single band means it has only one band. The bandwidth is available, but it is for the single band. But sometimes to enhance the bandwidth, you need a multiple band antennas. You can use a dual band also. एक तो बैंड रहेगा लेकिन बाद में साइड में एक और भी बैंड रहेगा. So when I measure the bandwidth at a minus 10 dB, that is basically the S11 parameter graph where the frequency versus reflection coefficient is measured on VNA, vector network analyzer. So there is a two bands which has a two center frequency, one band is one center frequency. So a standard antenna capable of meeting the system performance requirement usually offers the most cost-effective solutions, benefiting from easy and fast of the cell availability. On the other end, if size constraints are extremely tight or performance targets extremely high, a custom antenna may be needed to ensure timely delivery. Consulting suppliers early is recommended. The supplier needs to know the frequency band bandwidth, efficiency, link budget, and any multi-band requirements. These are the target parameters one has to decide at the time of system development. You must have some kind of, we can say that the range here. You must have some kind of the radiations, or rather we can say that the power level, because power is basically generated and it is a very costly business. Even high frequency generation is a costly business. So frequency generation means high frequency gives you a high power also. Signal of a high frequency base system is always larger than the small frequency based system. There is a direct relation also. We have to also see the EMC, as I said, compliance. This one is a test because your system, your all the component and the antenna, which is fixed up in the system, there must be a EMC compliance. Unnecessary radiation create a disturbance for the wireless system. So as far as EMC is concerned, the high frequency circuitry such as switching regulators powering various parts of the system or an unintentional radiator such as a current loop can cause the problems. If the EMC is left as an after throughout, common techniques applied as a quick fix such as a board level shielding can significantly impair the antenna's performance. Yes, within short time, we'll also start the EMC compliance at our campus in our My Lab. Under the umbrella of 5G, there are many technology projects like Internet of Things, in-vehicle communication, smart cities, e-health systems. To understand the concept of IoT, the authors first understand the revolution of technological networks and later discuss what is IoT is. The importance of antenna and future vision. The diverse ecosystem of Internet of Things bring along uncountable and device utilizing all sorts of radio modules, sensors, actuators, sensors, actuators, batteries, cells, MEMS, energy harvest techniques, and on the top of all antennas. The choice and design of the antenna is application dependent and various varies depending on the frequency range, transmission strength, and availability of space. As you know, unlike the high throughput wireless networks such as a 5G IEEE 802.11ax and Y gigabyte, which is working at 60 gigahertz, so utilize the vast continuous spectrum space, IoT network smartly transmit or receives the small chunk of data in an IoT networks in a various network topologies like a star, mesh, and or point-to-point. See here, without computer expert or IT experts, I think it is difficult to do the network or rather data communications. So most of the time, the job of establishing such type of link is accomplished by some common and relatively less complex types of omnidirectional antennas, such as a wire antennas, rubber, duct, patch, whip, PCB, and on-chip antenna structures. These are the few antennas which can be used in a IoTs, and that you must have used it also. Yeah. So several IoT developments kits and platforms such as Arduino GSM and Qualcomm IoE makes use of similar antenna structure for GPS, Bluetooth, and Wi-Fi communication. Some applications such as a medical body area network and wearable electronics also requires antennas to be a low profile and conformal to the surface of the device. And this pursuit the need of developing antennas specific to end device and tailored to meet specialized application of the requirements. Antennas for IoT can be either be categorized according to their bands of operations, means unlicensed ISM, as you know, it is used, it is free for industry, scientific and medical purpose. Frequency of this is 2.45 gigahertz, and that is commonly used in IoT development platforms. Whereas some applications are also includes antennas for license bands such as avionic applications. When I say IoT system, what is IoT ecosystem? It consists of sensors, it consists of gateways, it consists of the infrastructures, network infrastructures, and of course there is a cloud infrastructures, and that is the basic part of the IoT ecosystem. Big data and analytics is also a part and partial, because without that one cannot dream of the best IoT system. So this one is IoT ecosystems, what I said. And obviously there are the frequency bands and IoT applications. These are the different applications which is mentioned. Applications are over here, technology is this one, frequency band is this one. How it is useful for a medical application, how it is used for a smart home and smart buildings. I think Zigbee can also serve the purpose, GPS can also serve, Bluetooth, Z-Wave likewise. And smart agriculture, smart cities, LoRa is the best option for it. If I see the RF, what is the amount of distance can be covered and what is the data rate offered by this? So if you see the comparison of these two parameters, RF is now used in a more applications driving the development of protocols to meet the need of specific application. You see centimeters, you see the meters, then Z-Wave, Zigbee, Bluetooth, these are the range. But data rate is high. Wi-Fi gives the best, Bluetooth provide afterwards. But if I have an option to go the more than the meters, then LoRa can be a, I mean, in few kilometers, we can go with the Sigfox, neural LoRa, and cellular gives the highest in the data rate and the kilometers distance. These are the different types of antennas. Antennas come in a various shapes and size and materials. These are the also the antennas can be designed and manufactured to meet the most demanding space constraint, because sometimes what happens, the system should be a very compact, and that can be achieved by achieving the small antenna design. So embedded antennas can be extremely small and manufactured from ceramic and plastic as well as the stem metals, weighing just a few grams. Cable antennas can be made using PCBs, both rigid, FR4 and flexible materials. You can use the flexible material also, as well as the stem metal. This capability make it simple to find the most appropriate antenna design, whatever the applications. So microstrip antenna is the best choice to design the IoTs because of its nature. It may be a rigid, it may be a flexible, it may be a small in size, it may be a low profile antennas. Cost is also very small one. I cannot use a horn antennas directly. The big size of conventional antenna cannot be fitted, even though it has so much advantage. I have to go with the microstrip antenna because of its a nature of it can be easily integrated with the systems. So many, I mean, the experts, those who are sitting here, they might have gone through this. The design options include PCB mounted and remotely located. Often the application will dictate the most appropriate approach. This one is antenna built, and this one is the connectors like SMA. These are the PFA antennas. Within this, there is antenna. You can see it in the left side of the figures. In the figure, there is a right-hand side, there is a PFA structures. Even in the right-hand side of this board, PFA structure is there. Planar inverted antennas. And yes, we are supporting the industry and academics with this anechoic chamber. So the antennas which is developed, right hand side you see the antennas, microstrip antenna, which is developed by some of the students. So transmitting antennas receive some signal, unwanted signal, or rather the escaping signals can be absorbed by the absorbers, those who are sitting here, which is fixed up. It is absorbers. So it gives a signal, signal can be received, and unwanted signal, or rather the escaping signals, are not reflected back. And that's why it is the anechoic chamber. Ane means there is no any echo. That is only the word of it. A variety of standard antennas that are need to design for frequency appropriate to IoT application and also should be compatible with the extreme size and power constraint that apply to typical IoT endpoints is available. This one is the my conclusion. A variety of standard antennas that are need to design for frequency appropriate to IoT application and also it should be compatible with the extreme size and power constraints that apply to typical IoT endpoint. And obviously, there is a nevertheless successfully integrating an antenna is not a simple plug and play exercise. Requires careful selection, awareness of the effect of other components in the system, including the enclosure and fine tuning of the antenna's feed and positioning. It is worth keeping an eye on technical developments too. In the quest to usurp the trade-off between the miniaturization, efficiency, and bandwidth, researchers are investigating advanced materials such as graphene, leveraging its excellent conductivity to print thin and flexible antennas, dielectrically loaded polymers, and textile antennas for wearable applications. My few students are working on this flexible antennas, textile antennas also. This one is a references. Yes, the survey was done on IoT that is mentioned over here. Clark's three laws are used. Link budget, insertion loss. This is also very important. GSMA and the mobile economy and the businesswire.com global asset tracking market and what is the smart building trends and all is mentioned in the various places. This is my again the lab where I'm working. So I'm uh, handling this lab and I'm happy to be a part of this lab because I think in our life, if we can be we become a director or principals or the head of the department or the any authorities or not, but at least we must have a one lab and we should be known by the laboratory. That is the achievement of any professor. I'm trying to it, and it is again the so many difficulties are coming across, but I think we should work like anything. So this is from my side. Yes.
Yes, thank you so much, sir, for your wonderful talk.
Thank you. Thank you very much, madam.
Friends, if you have any questions, please ask.
Yes, they are welcome. Manita, madam.
Any doubt or any feedback?
Yes, please.
Hello, sir.
Namaskar.
Sir, namaskar. Sir, how is the physical structure of that graphene antennas?
Graphene antennas structure is basically supported with the another materials. Because if you see, as you know, sir, it is a graphene means it's a one kind of powder and all, right? So we have to support the some other structures. Let me say that basically it is used nowadays for the terahertz of the frequency.
Okay.
And yes, testing is somewhat difficult. And that's why must need some collaboration with the other countries, laboratories and experts, and they will help with this.
That means this graphene material is used as a receivers.
That can be used basically as a absorbers. More application of this
Okay.
one is absorbers.
Okay, sir. Thank you.
Anyone else?
Uh, Hello, sir.
Namaskar, sir. Namaskar.
Namaskar. Sir, I just want to know what properties a material should have to behave like an antenna. What basic properties that material should have?
Sir, first is it should be a conducting material.
Okay.
This is a very, very important properties, first thing. Second important thing
Mhm.
is when I basically I have to give a signal and there must be a structures which supports. So you have to change the, I mean, if I'm using a copper directly, cannot be given signal to that copper directly. So I have to maintain the structures in such a way that there must be a dielectric material between two conducting plane, like a capacitor kind of structure, sir. So when I
Yes,
energize
sir.
this one, so with respect to that, the patch and my ground plane, the field is produced. That is the fringing field, sir.
Yes, sir.
So basically, one should start with the FR4 because it is materials where the dielectric properties are also there. It has its own epsilon dielectric constant. And there are so many equation on this that how you can calculate the efficient dielectric constant, how you calculate the bandwidth of it, how you calculate the frequency operation, how you calculate the width and length of this patch on the microstrip antennas. So basically, conducting material can be radiated. That is very important. Conducting property is the main characteristics of antenna, sir.
Okay. Thank you, sir. And it must not be a metal. So it can it be any other metal than metal?
Metal, as I said, copper is a metal, sir, finally.
Yes, yes, sir. Yes, sir.
Right? So my point is the conducting materials. Means if I use
Okay.
a simple absorber, so like a rubber only, rubber cannot be radiated, sir, the
Yes,
signals.
yes, it
So
cannot.
any
Yes,
conducting
sir.
materials can radiate. Basically, you have to completely, I mean, you do these structures in such a way that that will enhance the efficiency.
Yes,
Directly
sir.
conducting material, maybe a copper plate, if I radiate it, if I give a signals, it can radiate, sir. But maybe
Yes,
the
sir.
radiation is not up to the mark, means efficiency is lower, sir. So you have to make a structure in such a way that where the dielectric material between the two conducting plane and you energize the upper patch and that gives the signals, that gives basically a fringing fields from the ground plane to this patch. That will have, I mean, it has a more amount of efficiency, sir. That is the aim of it, sir.
Sir, we can
And
use
sir,
a conducting polymer.
Yes, sir.
that was I am
Yes.
We
asking.
can use
Conducting
here
polymer.
conducting polymer.
See, sir, there are, see, madam,
Hmm,
yeah. Basically, what happened, madam? You can design anything because basically you have to calculate dielectric constant first.
hmm,
And I think so many institutes have this facility.
hmm,
To design it, I think you have to apply those things in the equations and what kind of radiation fields, like if I say that the simple microstrip antenna, so there is a transverse electromagnetic quasi-TEM waves are there. So what kind of field is produced, this amount can be observed on the some software. That is HFSS. So high frequency structured simulators or other softwares are there. So we have to use it and the available materials
hmm,
can be selected and see the output.
hmm.
If the output is sufficient, I think it gives a better dielectric constant, it gives a better radiations, and that can be measured.
Okay, sir. Okay.
Sir, excuse me, sir. Sir, if you are using strip antenna, it will produce some radiation. Am I right? Is it harmful to human beings?
Slowly, slowly, because I think your voice is also not getting perfectly, sir.
Yeah. Sir, we are
Tirumurti, sir.
using,
Na?
yeah,
You are Tirumurti.
yeah,
Yeah, please, sir. Please,
Tirumurti.
sir. Haji, please,
Sir,
sir.
we are using strip antenna.
Microstrip antenna. Yes,
Are
sir.
you hearing? Yeah, microstrip antenna. So it will produce a signal. It gets some radiated. Am I right?
Right, right.
Like, is it harmful to the human beings?
Sir, there are so many research are going on.
Yeah,
And
yeah.
if the frequency is increasing, we don't know because what happens, sir, this effect maybe comes after 10 years.
Yes.
As we are entering the 5G, the frequency is about 30 gigahertz, sir. So
Yeah,
the radiation effect and all is obviously, sir, it affects the brain and all, sir.
yeah.
And as you know, because there are so many research, and that's why Professor Girish Kumar from the IIT Mumbai, he has developed one system known as, we can say that the radiation shield. And I mean,
Uh-huh.
he has put these objections in so many newspapers, sir, about the radiation. And basically, what happened? The towers are on our buildings, and these
Yes,
towers are always creates a issue, sir. When the tower under the
yes,
tower you are living, it means you are living in the. It means you are living in the, as you know, sir, micro oven, sir. So radiation are always affected, sir. Yes, body, sir. But sometimes what happens, sir? We are basically, I mean, more, we are taking care of the development, and we are, I mean,
okay, sir.
the things are happen, sir. Yes, I know. And he
We
has
are more
put so
exposed to the
many
development.
objection. Yeah, he has put so many objection in this. But still, I think things are going on. I think we are waiting for the other few years, sir.
Thank you, sir. Thank you, sir.
Thank
Thank
you.
you.
Thank you.
Thank you so much, sir. Thank you.
Thank you. Thank you.
Thank you so much,
Yes,
sir.
madam.
Yes,
Aji, madam.
yes. Any more question? Sir, appreciation messages in the chat box.
Oh, thank you very much. Thank you. I
Yes.
think I am like you, and I am also learning. Every faculty, those who are present right now, thank you very much for your patience.
Thank you
Sometimes what
so much,
happened?
sir.
Yeah, thank you. Thank
Yeah.
you very much.
On behalf of UGC HRDC, I also extend my thanks to you, sir, for accepting our invitation and delivery of your session. Thank you so much, sir.
Thank you, madam. Thank you very much. We'll meet
Thank you.
again with the
Namaste,
another
sir.
assignment. Yeah.
Yeah.
Thank you.
Thank you, sir. Thank you,
Thank
madam.
you. Thank you.
थैंक यू ऑल ऑफ यू. चलिए, आपको 5 मिनट्स का ब्रेक अगर चाहिए होगा तो वी विल टेक 5 मिनट्स ब्रेक एंड विल बिगिन विथ सेमिनार ऑफ वन पार्टिसिपेंट. भरत सर,
Yes, ma'am.
हाँ, आप प्रेजेंट करेंगे कि मैं यहाँ से प्रेजेंट करना है?
मैम मैं करता हूँ यहाँ से.
जी,
शेयर का ऑप्शन दे दीजिए.
आई विल गिव यू शेअर ऑप्शन.
मॅडम मुडल साईट्सचं केव्हा घेणार मॅडम?
बस सरांचा
मॅडम
सेमिनार
आज
झाला की आपण सुरू करूया लगेच. 4 वाजेपर्यंत आपल्याला वेळ आहे.
हा तेच ते.
कारण 4 वाजता
मॅडम आज
हिरवडे
अजून एक टॉक
मॅडमचं,
आहे ना?
हो 4 वाजता हिरवडे मॅडमचं लेक्चर आहे ना.
हा हा ठीक आहे ना.
हा, IPR वरती. तर आता आपल्याला हा मधला जो स्पॅन आहे 3 ते 4चा, त्यामध्ये आपण सरांचं प्रेझेंटेशन घेऊ आणि त्यानंतर मी ते Moodle मधल्या ज्या पण डिफिकल्टीज आहे तुम्हाला त्या सॉल्व्ह करते.
Yes, मॅडम.
ओके. तर मीन वाईल ज्यांनी मोबाईलनी जॉईन केलं असेल, ज्यांना आता लॅपटॉपनी जॉईन करायचं असेल, तर तुम्ही मीटिंग लीव्ह करून परत जॉईन करा दुसऱ्या डिव्हाइसनी. मी डेमॉन्स्ट्रेशन देईल. जे टॉपिक्स तुमचे नाही समजले तर तुम्ही सायमल्टेनियसली पण करायचं असेल तर करू शकाल. ओके.
Yes, मॅडम.
येस. भरत सर, शेअर करून बघा.
Yes, ma'am. You see my slide?
Screen is visible but not PPT.
And is it visible?
No, sir. Actually, it is, I think, window of some other part. Start, join, schedule, settings. Kindly minimize this.
सस्टेनेबल ग्रोथ भी होना चाहिए। लेकिन आपको मैं एक बात बता देता हूँ कि हमारी जो टोटल नीड है, ग्लोबल नीड, द 70% द एनर्जी नीड कम फ्रॉम दी कन्वेंशनल सोर्स ऑफ एनर्जी। अब कन्वेंशनल सोर्स ऑफ एनर्जी क्या है? ये है, इट इज कम फ्रॉम दी नेचुरल गैस, ऑयल, कोल या न्यूक्लियर एनर्जी, जो फुलफिल करता है हमारी एनर्जी नीड को। बट हमें ये भी पता है इट ऑल्सो affect the environmental problem. It create the environmental problem such as water pollution, air pollution, and many things. So conventional energy source का एक पॉइंट ये भी है, इट इज नॉट प्रेजेंट इन अ लार्ज स्केल। लार्ज स्केल में हमारा ये जो कन्वेंशनल एनर्जी सोर्स है ये प्रेजेंट नहीं है। सो देर इज a need to go for the alternative source of energy such as the non-conventional energy source. So non-conventional energy source कौन से हैं? It is the bioenergy, tidal energy and wind energy and also the solar energy. But हमें ये भी पता है कि जो नॉन कन्वेंशनल सोर्स ऑफ एनर्जी है इसके कुछ लिमिटेशंस है। वी कैन नॉट क्रिएट दिस एनर्जी इन अ वेरी लार्ज क्वांटिटी। लार्ज क्वांटिटी में हम इस नॉन कन्वेंशनल एनर्जी सोर्स को क्रिएट नहीं कर सकते हैं, और साथ ही कुछ और भी बहुत सारे ड्रॉबैक्स इस नॉन कन्वेंशनल एनर्जी सोर्स के साथ मिले हैं। बट इट कैन बी प्रोड्यूस इन अ लार्ज स्केल। सॉरी, आई थिंक ये लाइन मेरी गलत हो गई यहाँ पे। it cannot be produced in a large scale. Now इसका अल्टरनेटिव क्या है? तो अल्टरनेटिव है हमारे पास में द फ्यूल सेल। So fuel cell can solve our problem. अब फ्यूल सेल क्या है? फ्यूल सेल is an electrochemical device that generate electricity by a chemical reaction. मैं आपको एक बात बता देता हूँ कि जो फ्यूल सेल है इट इज नॉट ए न्यू कॉन्सेप्ट। ये कोई नया एक नया कॉन्सेप्ट नहीं है। इट इज अ वेरी ओल्ड कॉन्सेप्ट. It was actually the first fuel cell was developed by सर विलियम ग्रोव इन 1839, जिसे उस वक्त कहा जाता था द गैस वोल्टाइक बैटरी। सो 1839 में इसका फर्स्ट इन्वेंशन हुआ था। बाद में इसमें कुछ मॉडिफिकेशंस हुए, तो आज के टाइम पे जो हमारा फ्यूल सेल है ये पहले वाले फ्यूल सेल से काफी अलग है। नाउ इसका वर्किंग क्या है? A fuel cell is electrochemical energy conversion device that convert the chemical energy of fuel, that is hydrogen, methane, butane or even a gasoline and diesel, into the electrical energy. तो ये क्या करता है कि हमारा जो फ्यूल सेल है ये जो हमारा हाइड्रोजन है, मीथेन है, ब्यूटेन या गैसोलीन, इस एनर्जी को यूज करके, इस केमिकल को यूज करके इसे इलेक्ट्रिकल एनर्जी में कन्वर्ट करता है। फ्यूल सेल कंसिस्ट ऑफ द मोस्ट इंपॉर्टेंट कंपोनेंट, नेमली एनोड, कैथोड एंड इलेक्ट्रोलाइट। इस फ्यूल सेल के जो मेन 3 कंपोनेंट है वो एनोड है, कैथोड है और इलेक्ट्रोलाइट है। इसमें जो इलेक्ट्रोलाइट होता है इट कैरी द इलेक्ट्रिकल चार्ज पार्टिकल्स फ्रॉम वन इलेक्ट्रोड टू अदर। अगर आप इस इमेज को देखें तो आप देख सकते हैं कि यहाँ पे एक फ्यूल सेल का एक डायग्राम है जहाँ पे लेफ्ट हैंड साइड में एक एनोड दिया है, उसके बाद में एक इलेक्ट्रोलाइट है सेंटर में, और राइट हैंड साइड में एक कैथोड दिया हुआ है। तो ये जो एनोड, इलेक्ट्रोलाइट, कैथोड है ये मिलकर बनाते हैं फ्यूल सेल। अब इनका काम क्या है? तो जो एनोड है इसमें होता है ऑक्सीडेशन रिएक्शन। ऑक्सीडेशन रिएक्शन क्या होती है? जब भी हम किसी एनोड को किसी हाइड्रोजन से एक्सपोज करते हैं तो उस हाइड्रोजन में से इलेक्ट्रॉन बाहर निकलता है। रिमूवल ऑफ इलेक्ट्रॉन इज नथिंग बट द ऑक्सीडेशन रिएक्शन। तो ये जो ऑक्सीडेशन रिएक्शन है ये परफॉर्म कहाँ हो रही है? एनोड भी हो रही है। उसके बाद में जो हमारा कैथोड पार्ट है इलेक्ट्रोलाइट के बाद वाला, वहां पे होता है रिडक्शन रिएक्शन। इसमें क्या होता है कि जो इलेक्ट्रॉन एनोड में ऑक्सीडेशन की वजह से निकला है वो एक्सटर्नल सर्किट के थ्रू ट्रैवल होके कैथोड में आता है, तो वहां पर रिडक्शन रिएक्शन के जरिए वो जो इलेक्ट्रॉन है वो कैथोड क्या करता है, उसे एब्जॉर्ब कर लेता है। तो यहाँ पे जो रिडक्शन रिएक्शन है इसका मतलब क्या हुआ? तो एब्जॉर्प्शन ऑफ इलेक्ट्रॉन। तो ये इसके 2 प्रोसेस है। और यहाँ पे सेंटर में जो इलेक्ट्रोलाइट मटेरियल है उसका काम सिर्फ ये है कि ऑक्सीडेशन रिएक्शन से एनोड में जब ऑक्सीडेशन होगा वहां से जब इलेक्ट्रॉन निकलेगा तो जो हाइड्रोजन है ये एक आयन में कन्वर्ट हो जाएगा। अब ये जो आयन है ये ट्रैवल करेगा इस इलेक्ट्रोलाइट मटेरियल से फ्रॉम एनोड टू कैथोड। अब ये जो कंडक्शन का जो पार्ट है ये आयंस का, ये है आपके इलेक्ट्रोलाइट का। इज इट मैम? मेरी आवाज आ रही क्लियरली? हेलो?
Yes, yes.
ओके। नाउ सो एनोड में किस टाइप की रिएक्शन हो सकती है आप यहाँ देख सकते हो, और एक राइट हैंड साइड में मैंने एक एनिमेशन दिया है। कैन यू सी द एनिमेशन हियर?
यस सर।
ओके। तो एनोड साइड में रिएक्शन देखिए कि हमने एनोड को यहाँ पर एक हाइड्रोजन दिया है, उस हाइड्रोजन में से 4 इलेक्ट्रॉन्स बाहर निकल गए, और ये जो 4 नंबर ऑफ इलेक्ट्रॉन्स है, इस राइट हैंड साइड वाले में आप इमेज इन एनिमेशन में देख सकते हो कि वो उस एक्सटर्नल सर्किट से पास हो रहा है। जैसे ही वो इलेक्ट्रॉन एक्सटर्नल सर्किट से पास होगा, वो चला जाएगा कैथोड के पास में। अब कैथोड में कौन है? कैथोड में है हमारा ऑक्सीजन। हमने एनोड की तरफ से हाइड्रोजन को सप्लाई किया है और कैथोड की तरफ से ऑक्सीजन को सप्लाई किया। ये जो ऑक्सीजन एटम है, ये एक्सटर्नल सर्किट से आने वाले इस इलेक्ट्रॉन को एब्जॉर्ब करेगा, और एब्जॉर्ब करने के बाद में हमें यहाँ पे बाय प्रोडक्ट जो मिलता है वो मिलता है वाटर। तो जो नेट रिएक्शन आप यहाँ देख सकते हो, 2H2 plus O2 gives to the twice of H2O. नाउ फ्यूल के कितने टाइप्स है, फ्यूल सेल के कितने टाइप है? तो यहाँ पे 6 तरीके के टाइप्स है। द पॉलीमर इलेक्ट्रोलाइट मेम्ब्रेन फ्यूल सेल एक है, सॉलिड ऑक्साइड फ्यूल सेल एक है, मोल्टन कार्बोनेट फ्यूल सेल एक है, अल्कलाइन फ्यूल सेल एक है, फॉस्फोरिक एसिड फ्यूल सेल एक है, और डायरेक्ट मिथेनॉल ये एक फ्यूल सेल है। बट द मोस्ट इंपॉर्टेंट फ्यूल सेल इज द सॉलिड ऑक्साइड फ्यूल सेल। नाउ इन सभी फ्यूल सेल को हमने इसके ऑपरेटिंग टेम्परेचर के बेसिस पर डिवाइड किया है। आप देख सकते हो, तो फ्यूल सेल जैसे कि अल्कलाइन फ्यूल सेल है, वो 100 से 250 डिग्री सेल्सियस पे काम करता है, और इसकी इफिशिएंसी 70% तक जाती है। इसकी एप्लीकेशन एरोस्पेस में, अंडर वाटर इन्वायरमेंट में इसका यूज होता है। फॉस्फेट बेस यहाँ पे हमारे पास में फ्यूल सेल है जो 166 से 220 डिग्री सेल्सियस पे काम करता है, और 80% इसकी इफिशिएंसी है। और हाई एनर्जी डिमांड जैसे कि हॉस्पिटल, स्कूल, ऑफिस, स्टोर्स में इसका एप्लीकेशन देखा जाता है। देन मोल्टन कार्बोनेट है जो 650 डिग्री सेल्सियस पे काम करता है, और इसकी एफिशिएंसी 60 से 80 है, और वेस्ट वाटर ट्रीटमेंट प्लांट में भी इसका यूज होता है। सॉलिड ऑक्साइड फ्यूल सेल विच इज द मोस्ट इंपॉर्टेंट फ्यूल सेल, सबसे ज्यादा रिसर्च होता है, वो होता है सॉलिड ऑक्साइड फ्यूल सेल। इसका जो ऑपरेटिंग टेम्परेचर है ये 800 से 1000 डिग्री सेल्सियस के आसपास है, और 60% इसकी एफिशिएंसी है। जनरेटर फॉर द फैक्ट्रीज एंड टाउन्स में इसका इस्तेमाल होता है। डायरेक्ट मेथनॉल भी एक है जो 120 डिग्री सेल्सियस पे काम करता है। इसका इफिशिएंसी थोड़ा बाकी के कंपैरिजन में काफी कम है, दैट इज 40% ओनली। सेल फोन, लैपटॉप, बैटरी चार्जर्स इसका इस्तेमाल होता है। देन प्रोटॉन एक्सचेंज मेम्ब्रेन जो 60 से 100 डिग्री सेल्सियस पे काम करता है, तो 85% तक का ये इफिशिएंसी दे सकता है। और व्हीकल, बैटरी, कमर्शियल बिल्डिंग एंड होम्स में इसका यूज होता है। नाउ इसमें एक क्वेश्चन डेवलप होता है कि व्हाट इज द ऑपरेटिंग टेम्परेचर। मैंने जैसे आपको यहाँ पे बताया कि हम एनोड में फ्यूल देते हैं एज अ हाइड्रोजन, और कैथोड में हम देते हैं ऑक्सीजन। यहाँ पे ऑपरेटिंग टेम्परेचर क्या है? एक्चुअली इस पूरे फ्यूल सेल को हमें ऑपरेट करने के लिए एक ऑपरेटिंग टेम्परेचर की जरूरत है। जब तक हम ऑपरेटिंग टेम्परेचर देंगे नहीं, तब तक ये रिएक्शन पॉसिबल नहीं होगी, क्योंकि जब तक यहाँ पे हीटिंग ट्रीटमेंट नहीं होगा, तब तक यहाँ से आयंस जो है इस इलेक्ट्रोलाइट मटेरियल से एक जगह से, यानी कि एनोड से कैथोड की तरफ या कैथोड से एनोड की तरफ में ट्रांसफर नहीं होंगे। इलेक्ट्रोलाइट मटेरियल का काम यही है कि वो आयंस को ट्रांसफर करे, और जो हमारे एनोड और कैथोड का काम ये है कि वो आयंस को और एज वेल एज जो इलेक्ट्रॉन है उसे इजीली एनोड से कैथोड की तरफ, यानी सर्किट से वो उसे पास करे। इलेक्ट्रोलाइट मटेरियल को हम हार्ट ऑफ द फ्यूल सेल भी कहते हैं। नाउ अब इसके एडवांटेज क्या है? फ्यूल सेल के एडवांटेज ये है, इट मिनिमाइज द रिलायंस ऑन द पेट्रोलियम प्रोडक्ट फॉर एनर्जी। पेट्रोलियम प्रोडक्ट इज इन लिमिटेड सप्लाई। हमें पता है कि पेट्रोलियम प्रोडक्ट्स जो है ये लिमिटेड सप्लाई है में प्रेजेंट है। नेचुरल गैस इज हार्ड टू ट्रांसपोर्ट एंड कोल इज वेरी डैमेजिंग टू द इन्वायरमेंट। सो फ्यूल सेल प्रोवाइड एन इनएक्सपेंसिव एनर्जी इन द फॉर्म ऑफ इलेक्ट्रिसिटी. They can ultimately satisfy our demand for energy without relying on the rapidly decreasing supply of fossil fuel. We all know that कि जो क्रूड ऑयल के जो प्राइस है ये डे बाय डे बढ़ते जा रहे हैं, तो हमें एक अल्टरनेटिव सोर्स की जरूरत है। तो जो एक फ्यूल सेल है, इट कैन बी गुड अल्टरनेटिव ओके ओवर द कन्वेंशनल एंड द नॉन कन्वेंशनल सोर्स ऑफ एनर्जी। दूसरा इसका एक एडवांटेज ये है, ये लेस ग्रीन हाउस गैस इमिशन। हमें ये पता है कि जो भी फैक्ट्रीज है, इंडस्ट्रीज है या गाड़ियां हैं, ये काफी कार्बन डाइऑक्साइड रिलीज करते हैं। उसकी वजह से क्या होता है कि ग्रीन हाउस इमिशन बढ़ जाता है। ग्रीन हाउस इमिशन अगर बढ़ जाएगा तो क्या होगा कि ग्लोबल वार्मिंग बढ़ सकती है, अर्थ का जो टेम्परेचर है वो बढ़ सकता है। लेकिन फ्यूल सेल यहाँ पे भी एक अल्टरनेटिव साबित हो सकता है, क्योंकि फ्यूल सेल जो है, जो मोस्ट ऑफ द, अगर हम हाइड्रोजन एज अ फ्यूल लेते हैं तो वहां पर ये होता है कि हमें जो बाय प्रोडक्ट मिलता है वो वाटर मिलता है। लेकिन कुछ ऐसे भी फ्यूल सेल है जहाँ पे कार्बन डाइऑक्साइड रिलीज होता है, बट वो काफ़ी कम अमाउंट में होता है। तीसरा इसका डिसएडवांटेज ये है कि नो डिग्रेडेशन, जैसे कि बैटरी जो है ये काफ़ी जल्दी डिग्रेड होती है, लेकिन फ्यूल सेल यहाँ पे नहीं है। फ्यूल सेल जो है जब तक आप इसको कंटिन्यूसली फ्यूल सप्लाई करोगे तब तक ये आपको एनर्जी देता रहेगा। अब इसका डिसएडवांटेज भी है। फ्यूल सेल का डिसएडवांटेज ये है कि इसका ऑपरेटिंग टेम्परेचर काफ़ी हाई है। अगर हम देखें कि 200 डिग्री सेल्सियस से भी अगर हम 1000 डिग्री सेल्सियस पर जाते हैं तो इट इज़ क्वाइट नॉर्मली हायर दैन दी रूम टेम्परेचर, और इस टेम्परेचर को अटेन करने के लिए थोड़ा सा समय लगता है। इसीलिए इसका जो सेकंड डिसएडवांटेज ये है, इट इज़ अ वेरी स्लो प्रोसेस। ओके, तो ये फ्यूल सेल जो है इसमें जो प्रोसेस है काफ़ी स्लो है, क्योंकि इसमें जो इसका ऑपरेटिंग टेम्परेचर है वो ज़्यादा है। तीसरा है थर्मोकेमिकल इंस्टेबिलिटी ऑफ द सेल इंडिविजुअल लेयर। यहाँ पे क्या है कि हमने 3 कंपोनेंट का इस्तेमाल करके एक फ्यूल सेल बना है, जिसमें एनोड है, कैथोड है और इलेक्ट्रोलाइट मटेरियल है। तो यहाँ पर अ, क्या होता है यहाँ पे कि जो थर्मोकेमिकल स्टेबिलिटी है वो वहाँ पे खराब हो सकती है। मतलब क्या है कि जब हम इसे हीट करते हैं, जैसे कि हमने कहा कि दैट द फ्यूल सेल ऑपरेट ऑन अ ऑपरेटिंग टेम्परेचर, तो अब जैसे ही हम देखेंगे यहाँ पे कि एनोड, कैथोड और इलेक्ट्रोलाइट मटेरियल, इसे अगर हमने हायर डिग्री सेल्सियस पे हीट किया, जैसे कि यहाँ पे कहा है कि आपका जो सॉलिड ऑक्साइड फ्यूल सेल है वो 800 से 1000 डिग्री सेल्सियस पर वर्क करता है। अब ये हो सकता है कि मैंने अगर कोई कंपोनेंट बनाया है, जैसे कि एनोड मैंने किसी मटेरियल से बनाया है, लेकिन जो एनोड है ये सिर्फ और सिर्फ 500 डिग्री सेल्सियस तक ही टेम्परेचर को सस्टेन कर सकता है। तो यहाँ पर क्या होगा, मेरा जो वर्किंग टेम्परेचर है सॉलिड ऑक्साइड फ्यूल सेल का वो 800 डिग्री सेल्सियस का है, बट यहाँ पे मेरा जो एनोड मटेरियल है जिससे मैंने उसे बनाया है, इट इज जस्ट वर्किंग ऑन दी 500 डिग्री सेल्सियस। तो यहाँ पे एक इंस्टेबिलिटी आ सकती है, जिससे हमारा जो सेल है ये इनस्टेबल हो जाएगा। चौथा पॉइंट है फ्यूल सेल इज कॉस्टली। द मटेरियल बाय विच कंपोनेंट ऑफ फ्यूल सेल कैन मेड इज वेरी कॉस्टली। जो चौथा सबसे मोस्ट इंपॉर्टेंट है कि फ्यूल सेल को बनाना ये बहुत ही कॉस्टली है। मैं आपको एक बात बता दूं कि मैंने मेरे रिसर्च में, एक्चुअली ये मेरे रिसर्च का पार्ट है जिसमें मैं इलेक्ट्रोलाइट मटेरियल को डेवलप कर रहा हूँ। तो यहाँ पर मुझे गैडोलिनियम नाइट्रेट नाम का एक केमिकल लेना था जो मुझे डोप करना था अपने इलेक्ट्रोलाइट मटेरियल में। 25 ग्राम्स का मैंने केमिकल लिया और इसका कॉस्ट ऑलमोस्ट 14,000 है। जो 14,000 एक्चुअली उतना ज़्यादा नहीं है, लेकिन जो क्वांटिटी है वो 25 ग्राम्स है सिर्फ। तो 25 ग्राम्स का मैंने लिया और उसका कॉस्ट हुआ मुझे 14,000। तो इट इज़ वेरी कॉस्टली। एप्लीकेशन एरिया वैसे मैंने आपको ऑलरेडी बताया है, बट यहाँ हम देख सकते हैं कि स्टेशनरी पावर सिस्टम में रेजिडेंशियल एप्लीकेशन आ जाते हैं, कंबाइन हीट एंड पावर सिस्टम हो गया, डिस्ट्रीब्यूटेड पावर जनरेशन में हम इसका यूज़ कर सकते हैं, ट्रांसपोर्टेशन एप्लीकेशन में कार, बसेस, यहाँ पे हम इसका यूज़ कर सकते हैं। देन पोर्टेबल सेल जैसे कि मोबाइल फ़ोन, लैपटॉप, यूपीएस, यहाँ हम इसका इस्तेमाल कर सकते हैं। स्पेस एप्लीकेशन में भी हम इसको यूज़ कर सकते हैं। Now, conclusion part. Fuel cell is very costly to manufacture. It is a very slow process and also require high temperature to perform the chemical reaction. Hence, fuel cell need a lot of research. By increasing research and development in the area of fuel cell technology, will help to overcome the drawbacks of fuel cell. तो यहाँ पर लास्ट फाइनल क्वेश्चन यही है कि फ्यूल सेल में जितना ज़्यादा रिसर्च होगा उतना ज़्यादा उसका फ़ायदा होगा, क्योंकि फ्यूल सेल बहुत ही कॉस्टली है, स्लो प्रोसेस है। और मैं अपने रिसर्च में ये ट्राई कर रहा हूँ कि लो टेम्परेचर पे मेरा इलेक्ट्रोलाइट मटेरियल मुझे हाई आयनिक कनेक्टिविटी दे, क्योंकि जब तक मुझे हाई आयनिक कनेक्टिविटी मिलेगी नहीं तब तक मेरे आयंस जो है एनोड से कैथोड में पास होंगे नहीं लो टेम्परेचर पे। तो अगर मैं चाहता हूँ कि मेरा रिसर्च अच्छा हो तो उसका सिर्फ एक ही मेरा जो ऑब्जेक्टिव है वो यही है कि मुझे लो टेम्परेचर पे हाई आयनिक कनेक्टिविटी परफॉर्म करानी है। These are some references. Thank you.
Thank you so
Ma'am,
much, Bharat sir. Yes, very nice work. And all the best for your research. Thank you.
thank you, ma'am. Thank you, ma'am.
Thank you so
Actually, मैम
much.
हुआ नहीं था, बहुत जल्दी मैंने 2 दिन में स्लाइड
Yes.
बनाई है।
ठीक है
Actually,
sir,
कुछ
but your
मुझे पता नहीं
vision is clear. What you have to do, what are your objectives and what you want. That is more important. Yes sir.
थैंक यू मैम, थैंक यू
Nice.
वेरी मच।
तो चलिए फ्रेंड्स, आज तो बाकी के सेमिनार्स नहीं है, बाकी सेमिनार्स हम कल लेंगे। नाउ वी विल प्रोसीड विथ आवर पार्ट ऑफ Moodle. Just let me stop this recording.